Bismillahirrahmanirrahim. Today we will discuss three joining processes. As you people have already discussed about the welding, so then the rest of three joining processes are: number one is brazing, second one soldering, and the third one is adhesive bonding. So I will discuss the three topics with you people: soldering, brazing, and adhesive bonding. So first of all, we will get a little overview about the brazing and the soldering. Both of these processes use filler metals to permanently join metals, but there is no melting of the base metals. As I have teach you in welding processes such as arc welding, fusion welding processes, that the melting of the base metal occurs. At what point? At the fusing surfaces, the surfaces which are to be joined at where the welding is performed. When to use? The question arises: when to use brazing or soldering instead of fusion welding? So metals have poor weldability. Dissimilar metals are to be joined. Means the brazing can be used or soldering can be used for metals that have poor weldability. When we have to join two dissimilar metals, as you have clearly seen in the tools of the lathe machine, that a tip has been or tools of the lathe machine or any other tools in which a tip is joined with the base using the brazing operation. Intense heat of welding may damage component being joined. It is again repeated that in the welding operation process, in the welding process, the intense heat of the welding damages the internal structure of the parts, due to which mechanical properties changes. Geometry of the part not suitable for welding. It means that the high heat of the welding process disturbs the geometry of the joint. Example, just like angular distortion, longitudinal distortion, these type of distortion affects the geometry of the part. High strength is not required. Welding provides us a joint with the high strength, and in comparison, when we do not when we do not need high strength joint, we use brazing or soldering. Brazing is a joining process in which a filler metal is melted using heat and distributed by the capillary action. So capillary action means between the fusing surfaces. It's a clearance basically. You people can watch the videos on the YouTube about the capillary action of the liquid in the brazing joint. Capillary action works when there is a small clearance between the parts. However, for the capillary action, the clearance should be selected wisely. If there is too much clearance or too little clearance, brazing for the brazing joint, capillary action will not be take place. Further, the surfaces on which capillary action is to be performed should be free from the grease, oil, or any other external material. No, in brazing joint, no melting of the base metal occurs, only the filler metal melts. Further, there is a rule that in the brazing joint, filler metal TM temperature is greater than 450 degrees centigrade. The melting point of the filler metal is greater than 450 degrees centigrade, but it is less than the melting point of the base metals. I repeat again, this is a difference, or this is a principle of the brazing. The principle of the brazing is the capillary action. However, there is a difference between the soldering and brazing temperature wise, and the difference is that in case of brazing, the filler metal melts at above 450 degrees centigrade, but at lower than the melting point of the joints to be welded. The application of the brazing very obvious, from in automotive, electrical component, cutting tool, braze cemented carbide, to the shanks, jewelry, chemical industry, plumbing, heating, pipes, repair, and the maintenance work. How we will apply the filler metal? So there is a torch. Torch means heating torch, from where he will provide the heat. There is a filler rod. Okay, the filler rod is melted using the torch, and there is a clearance is meant to be maintained between the parts to be joined. This clearance should be selected very wisely. When the filler rod melts, through the capillary action, the filler metal distributes itself evenly between the clearance, and on the solidification, this joint will be formed. So this is another example, parts to be joined, and there is a minute clearance between the parts. One parts on which there is a there are no lines, no shading, and a part that have shading. So there is a minute clearance in between these two. Okay. In other words, in a ring, in a circular ring, there is another part has been assembled, and we have to form a permanent joint of these two parts. So bracing is performed. Okay. So bracing, as compared to the welding, all metals can be joined, including dissimilar metals, can be performed very quickly, consistently, producing high production rates. Multiple joints can be brazed simultaneously. Less heat and power required than fusion welding. In case of fusion welding, I have told you that the temperature required is about 55 degree 100 centigrade. Whereas in brazing, the temperature required is only is above 450 degrees centigrade. There's a huge difference between the temperature requirements, heat requirements. Problem with the heat affected zone in the base metal. What is heat affected zone? As earlier discussed, heat affected zone is a zone that is connected with the weld interface. It's a part of the base metal on which the heating and repeated heating and cooling of the base metal has altered the microstructure of the base metal, due to which this portion of the base metal has different mechanical properties. In most of the cases, in case of when we test tensile test, when we perform tensile test or impact test, the specimen breaks from the heat affected zone. So it's the mechanical properties of heat affected zone will are deteriorated in the welding too much. Joint areas that are inaccessible by many welding processes, those joints that can't be welded. So the second option is brazing. Capillary action draws the molten metal into the joint. If in the capillary action you have maintained the exact clearance between the two joining parts, the metal flows in the upward direction against the gravity. You people can watch it on YouTube videos. Disadvantage is joints such as very weak. Joints likely be less than very weak than welded joint. Joint strength is again less than the base metal strength. High surface temperature may weaken, means if you have a braze joint and you're using the part at higher temperatures, it will weaken the braze joint. Color of the brazing may not be matched with the color of the base metals, or with and a possible aesthetic disadvantage it appears in the brazing process. So basically, brazing is used for the mechanical joints. Now, soldering. Soldering is a joining process in which a filler metal with a melting temperature less than 450 degrees centigrade is melted and distributed between the fairing surface of the part. Again, you should have to evenly. I will explain the capillary action later on. No melting of the base metal, but melting of the filler metal occurs. The filler metal wets and combine with the base metal to form metallurgical bond. Uh, I was talking about in the previous laboratory class, lab class, you people have performed this experiment soldering. You people have worked with a solder or soldering iron and a soldering wire, and you have joined a few wires, copper wires. The soldering as brazing to similar, and many of the heating methods are used in soldering. The heating method is used. I think the heating method that is used is a electrical energy that converts into heat energy and melts the soldering wire. Filler metal is known as solder, most closely associated with electrical and electronic assemblies, wire soldering. So filler metal is known as solder, and the equipment that is being heated is known as soldering iron. Advantage is low energy Then brazing or fusion welding, variety of heating methods are available, good electrical and thermal conductivity. So that's why I have told you that soldering joints are used in the electrical components. Just like you have saw that soldering process perform in the markets on the electronic circuit boards. Easy repair work most commonly used in the repair and rework. However, there are few disadvantages associated: low joint strength, weakening of the melting joint at high temperatures. Shoulders, the shoulder you have saw in the laboratory is made up of on the same composition as written in the slide. It usually alloys of tin and lead. Both have low melting temperatures. Lead is poisonous and its percentage is minimized in most solders. Tin is chemically active at soldering temperature and promotes wetting action for the successful joining. In soldering, Copper, copper and tin form intermetallic compound that strengthen bond. Silver and antimony also use soldering alloys. So there is a huge variety we have in the solders. The third one is adhesive bonding, in which the use force of attachment between a filler metal and the two closely spaced surfaces to bond the parts. Filler metal in the adhesive bonding is not a metallic, these are basically polymers. Joining processes can be carried at the room temperature or above the room temperature. Adhesive, the word adhesive is used for a filler metal that is non-metallic, usually it's a polymer. Adherents, the parts, the two parts or three parts that are to be joined are known as adherents. Structural adhesives of great interest in engineering, capable of forming strong permanent joint between strong rigid adherents parts. So structural bonding or adherence means parts. During in the adhesive bonding, a process in which physical properties of the adhesives are changed from liquid to solid, usually by the chemical reaction to accomplish the attachment of the parts. Curing is often aided by heat or a catalyst. If heat is used, temperatures are relatively low. Curing takes time, a disadvantage in the production because the more the time, less will the production rate. Pressure sometimes applied between the parts to activate the bonding. Joint strength depends upon the adhesive, means the filler metal, a polymer mean. Attachment between adhesive and adherents, how you are going to attach, how you are going to design the joint. Attachment mechanisms, chemical bonding, adhesive and adherent form primary bond on curing. Physical interactions, secondary bonding forces between the surface atoms, mechanical interlocking, roughness of the adherent causes adhesive to become entangled in the surface asperities. There are few designs, it's obvious through butt joint, T joint, corner joint. Where the applications automotive aircraft and building products, packaging industries, footwear, furniture, see. Surface penetration. For adhesive bonding to be succeeded, part surfaces must be extremely clean. This should be take care in all of these three processes or even in welding processes. This is a major requirement to gain the strength. Bond strength depends upon the degree of adhesion between the adhesive and adherent, and this upon depend upon the cleanness of the surface. For metal, solvent wiping, often used for cleaning and abrading surfaces by sandblasting, improves the adhesion. Sandblasting is a process that have discussed in the class in which in this process sandblasting, the rust or any other impurity has been removed from the surface of the metals. For non-metallic parts, surfaces are sometimes mechanically abraded or chemically etched. Etching is a chemical process in which surfaces of the parts are cleaned using a solution which is acidic in nature to increase the roughness. Basically, in the etching process, a nitric acid solution, 4% nitric or 3% nitric acid solution is used on which the parts are dipped in order to clean the surfaces. Advantages of adhesive bonding applicable to a wide variety of the materials. Bonding occur over the entire surfaces, low temperature curing, avoid damaged parts being joined. It can be used for the sealing as well as bonding. Joint design is often simplified. Two flat surfaces can be joined without providing special part features such as screw hole or nut and bolts. Limitations: joint generally not as strong as other joining methods. Its strength is low. Adhesive is compatible with most of the materials. Service temperatures are limited. Cleanliness and service preparation prior to the application is very important. Curing time can limit production rates. Inspection of the bonded joint is very difficult. However, this inspection is very easy in case of, you can say, a welding joint.